All right, I see some people starting to stream in. We'll get started in about a minute and let more people get into the room. All right. Well, welcome everybody. Thank you for joining. My name is Colin Nagel. I am with the marketing team over here at Quali. We are excited to get kicked off with our Kubernetes workshop. This is our latest in a series of webinars where we focus on some of the common challenges that our users face. So just to set the stage a little bit, we're going to kick things off by touching on the challenges a little bit. I'm joined today by our field CTO, Tomer Adman. You'll hear from him in a minute. I promise we won't bore you to death with too many slides, but we think it helps to set the stage a little bit. Introduce what we talk with our customers about, what our users are facing, and then from there we're going to dive into a workshop. Right, the majority of this is going to be a hands-on keyboard workshop. We're showing what we do to solve those challenges, basically what we do to make your lives easier. One more reminder: this is a workshop, so this is collaborative. Right, please feel free to submit any questions you have through the Q&A. My team will be on the back end, making sure Tomer sees all of those. At the end of the session, we'll go through the questions and answer as many of those as we can. Without any further ado, I'm going to hand it over to Tomer to kick things off. Thanks, everybody.
Great. Thank you, Colin. And thank you all of you for joining us today. As Colin said, please go in, try, take a look. We're going to share the trial link for the tool very soon, so you will be able to follow us. And without saying too much, let's just jump right into the topic of today, which is Kubernetes. And I guess that most of you already heard about it. Maybe not all of you are using it in production or in your dev lifecycle, but Kubernetes is really one of the standards these days. People that are building new stuff would like to use it. All of us probably understand the value of using Kubernetes as an orchestrator for containers. Containers are really a best practice at this point. And in order to use Kubernetes, we need all kinds of stuff. And that's some of the things we're going to talk about today. Now, when I say Kubernetes, it's not just running application on Kubernetes. Regardless if you are a developer, a DevOps engineer, or an IT infrastructure engineer, Kubernetes is something that is in the core of the business. So we need to know how to architect around it. We need to know how to build Kubernetes cluster, maintain them over time, upgrade them. We need to be able to test, enable Kubernetes environment to our developers and QA engineers, and eventually maintain a Kubernetes cluster in production. Now, this is easy to say, but as we scale with our application and with our deployments, as we maybe need to add compliance features, maybe we need disaster recovery programs, things started to be a little bit more challenging. Now, software today is really around how we can build fast, how we can scale fast, how we can really be first in this time to market race. Now, Kubernetes really helps us with that. We can run it anywhere we want, regardless if that's public cloud, private cloud, on-premise deployment, tiny VMs, maybe using K3s or tiny Kubernetes deployments. We can deliver containers, which are really a standard way to build, package software in a very nice way. We can then ship them using different methodologies. And all in all, we want everything to be as code. Kubernetes really helps us with that. And we want to build an automated workflow in our software development lifecycle to eventually be able to maybe get to a fully continuous delivery process where things are being built, test, scan for security vulnerabilities, packaged the right way, and then shipped to production as fast as possible. Now, with that, and by the way, it doesn't have to be Kubernetes. What I wanted to talk about a little bit is how we are really streamlining Kubernetes and application throughout the software development lifecycle. Now, the secret sauce here and how Quali likes to look at things in this process is really the notion of environments. Environments is one of the core building blocks that we need in our life as software developers or as a production engineer to actually make sure our software meets the market. So we need environments for testing, we need environments for developing, for debugging, for reproducing issues that were reported by our customers, and obviously we need our production to bring business to our company. Now, environments are usually built out of main three things: infrastructure, our application, and some data. That's usually the basic for bringing to life something that's meaningful for the business. Now, regardless if those applications are running on VMs or containers or serverless, we need to be able to have this context of environment in order to ship those environments to the people that needs them. A developer won't be able to develop without a proper environment. Maybe the laptop he's using is the right thing. Maybe you can use Kubernetes on top of Docker for Linux, but maybe in an AI situation, you need GPUs that are not available on the laptop, the personal laptop of the developer. So you need to run on remote environment. The tester will need probably from tiny environments to production-like or performance environment in specific scenarios. So the environment should include everything needed, maybe including the testing environment, the testing tools in order to test. Then security and DevOps need environments to maybe build pipelines, maybe maintain existing environments, and SREs obviously need the production environment in order to do their job properly. Now, environments are hard. All right, environments usually are something that's really hard to scale, something that's composed out of many different automation tools. And this is really the infrastructure problems we want to tackle in this workshop and try to help you solve in your day-to-day. So let's start from left to right on this iceberg image, where the application is really just the tip, right? We need to execute something. Maybe it's a serverless function in AWS. Now, the code that's executed there might be tiny, might be very, very simple. But in order to run it, we need to configure so many different components in AWS. We need the account. We need loggers. We need Lambda configure right. We need an S3 bucket. We need all of that to be super secured. According to the company compliance program, we need that to be connected somehow to our software delivery system. So even if we just see the application here in the tip, we need so many things in order to build that environment that's eventually provide us a running Lambda function. Now, building all of those things is pretty hard. We have just a handful of experts in the company, and you can see that in the center of this slide. We have just a handful of people that can build something like that, and building that on demand is pretty hard. So maybe we'll go and try to automate that using Terraform, using CloudFormation, using other tools, and then we can scale the system or scale the organization, because eventually we need to provide that Lambda function to all of those that need that, like QA, testers, validation engineers, and developers that need to actually debug and build that. Now, those handful of people are super busy because obviously there is not just one Lambda function in the company. There are hundreds and maybe hundreds of microservices or monolith applications that are running somewhere, and someone needs to handle that. So in this upside down pyramid, you can see the bottleneck right away, right? We have 10 people that are our DevOps team that can actually build those environments, that can actually build Helm charts, as an example, for Kubernetes. We have some people that are maintaining our CI/CD, and they're automation expert, but they really are not focused on deploying our application. But on the other side, we have so many people waiting for those environments to be up and running, and we cannot get that amazing velocity we're looking for while we are waiting for environments. Now, building environments is really key here, but we cannot do that using silos and using broken processes where each and every team builds different automation pieces from using different tools. As an example, the infrastructure team builds their AWS resources using Terraform, but the application team is using Ansible to deploy their code. Now, that pretty much creates a broken process, right? We need the environment request to be sent to the infrastructure team and then passed to the maybe application team or DevOps team. So we have so many different steps, and eventually we don't have one business process for building that entire environment, something that will be meaningful for the business. So what we are really offering here is the mindset, a way of thinking about environment slightly different. Let's try to imagine an environment is something that will be the complete business process from infrastructure to monitoring. So infrastructure, application, data, monitoring, logging, everything that's required for someone to work on an environment. And the way to do that is using environment as a service tools. And what I'm going to show you here in this workshop is really how Torque, our SaaS offering by Quali, is an example of environment as a service tool, an implementation of the notion of environment as a service. And what we're going to touch on is really 4 main steps. One is how we go in and discover your infrastructure. You already have all kinds of automation out there, Helm chart, Kubernetes manifest, Terraform files. We want to go there and utilize or use those existing automation, discover that, and normalize that into reusable building blocks that you can start, where you can start building your business process out of that. Now, that should take a few seconds. Next, we're going to help you model environments in a very easy way and enable those environments to the end user. At the end, what we want to show you is that once you have this environment as a service notion implemented, you can start gathering information about usage, who is using what, how much it costs us. It's not just the infrastructure, but it's the infrastructure, the application, the monitoring, and all the different scripts and all the different entities that were built for a specific business context. So these are the 4 steps we're really going to focus on in this workshop. And please, as Colin said, feel free to ask any question you want. I will try to answer them all a little bit later on. And with that, let's move to the demo portion of this webinar. So hopefully you can see the browser, and Colin, please let me know if that's fine. What you can see here is basically Torque. Torque is our SaaS offering by Quali. All right, and what I'm going to start with is this demand for environments. We talked about the fact that it's hard to scale environment. It's hard to provide environment in a timely manner, in a stable manner, in a repeatable manner. And what I want to show you here is really a tool that can provide the end user, a tester, a developer, a product manager, a sales engineer, access to environments very quickly. So this is a catalog of different environments built for specific business purposes in Quali. And what you can see here, let's take a look at this one, for example. So here's a web game that will be deployed on AWS. And let's say I want to use this specific configuration. Now, someone already built that for me, and we're going to tackle this in a few minutes, but I need this as a testing environment, all right? And I need that for the remaining of the day. That's going to be about for 4 hours. So I'm going to just launch it. And now as an end user, I'm getting access to an orchestration process that eventually going to create an environment just for me and will provide me all the information I need in order to access that environment. So what you can see here is that in really just a few clicks, the orchestration process starts. Now, you can see here 2 different building blocks or 2 different cubes that are somehow connected. The orchestration process is basically managing this deployment phase of the different tools. In this case, you can see 2 different Terraform blocks. Now, we've talked about those islands of automation, the fact that different teams create different automation processes. So in this example, you can see 2 different teams. One of them is a security team, and one of them is the application team that build 2 different automation scripts or 2 different Terraform modules in this example. The security team built something very, very simple, but something very powerful. It's a a Terraform module that deploys a KMS key according to the best practice of Quali. Now, this KMS key as a building block can be used in different environments, different blueprints, in order to build different configurations. Now, once that's deployed, we are moving to actually building the application. That's a single page application hosted on S3 in AWS. Eventually, once that will be deployed, me as an end user, I will get access to the application. Now, during this deployment, you can see the dependency mechanism in which we are basically implementing or we are passing information between the different processes, the different automation building blocks in this environment. Now, the KMS key basically in this case provide or outputs an ARN. This ARN is passed to the S3 bucket, and the S3 bucket can now be created in a more secured way. Now, in a few seconds, the environment will be ready for us, and we can start to drill into what happened behind the scenes. But first, let's go into this application. And again, let's say I'm a tester. I can just go ahead and just test our Tetris game that was deployed just for me in this example. Now, the two building blocks were created, but not just that. I can see now everything that was created behind the scenes. So out of those two different Terraform modules, we got a lot of different entities in the cloud. One of them is obviously the bucket. And I can see all kinds of information about that, like the region, the ACL, and more information about what was actually deployed. Now, it's not just that the system orchestrates this, so create a very interesting UI, very powerful automation behind the scenes, but we are also providing a lot of guardrails and extra policies around the deployment. So let's touch on that for a second, and then we will move on to something a little bit more interesting, where we are actually deploying Kubernetes native application. So in this specific deployment, we not only deploy those Terraform modules, we also enrich them with standardized tagging. Now, tagging is something crucial for the business in order to eventually gather BI information or get business insights about what was deployed, who deployed that, what team deployed that, and eventually get to a situation where cost information or FinOps can operate on top of the data in the cloud. So you can see here that Torque really enriched all of those cloud resources, those eight resources that we deployed with all of those tags. So for example, here's my email. Here is the space or the project we are under, the source, the cost center. So that's for a sales activity, for a demo specifically, and more information that can be configured in a centralized place. So you don't really need to have the tagging logic within the automation tool. You can let Torque do that for you. Now, let's move on to something a little bit more exciting, and that's going to be an environment I deployed earlier with a little bit more automation steps. Now, as we did before, we deployed two different building blocks based on Terraform. In this case, that's RDS, a PaaS service by AWS, a managed MySQL, an S3 bucket, again, storage in AWS. But then only when those infrastructure blocks are fully deployed and ready, we're deploying our microservice application. Now, again, we can see here all the different resources that were deployed. In this case, we have a lot more because we deployed a lot of different microservices and services into our Kubernetes cluster. In this case, by the way, it's a shared Kubernetes cluster, so we haven't really deployed the Kubernetes itself, but obviously you can deploy an EKS and then deploy your application on top of it to encapsulate everything you need in order to run a specific application on a cluster. That's just one example. So you can see here all the different Kubernetes entities, and you can actually get access to the application itself. Now, before we go even deeper, let's understand how we create those building blocks. All right. So I'm just going to move to a different project, and I'm going to show you that Torque is really connected to your source control repository where you're usually saving your IAC files. Now, Torque has a capability to discover IACs And we are supporting many different IAC types. And you can see here that out of that GitHub repository in this example, Torque discovered Terraform, Helm, Kubernetes, and CloudFormation assets. Now, what we usually see with our customers is that different repositories have different IACs, but in a lot of cases, we see mixture. So we want to provide a very quick and easy way to model those as blueprints, so you can reuse those in different configuration. So let's just take this Terraform module as an example, and let's take this Helm chart as an example, and let's generate a blueprint or blueprints out of them. So what you can see here is that basically Torque, let's open that on a bigger, let's open the Helm one. So what Torque did behind the scenes is really discover the asset and then generated a blueprint, a very simple manifest on top of that asset that can now help me launch this asset very quickly. You can see here all the inputs I'm required to provide in order for this automation asset to be launched. And I can have commands and other interaction points with the deployment process in order to deploy different types of automation assets. Now, that's all I need in order to be able to kind of import this configuration into Torque. By the way, we are not saving the actual IAC. It's just a manifest to describe that. And now I can just launch this exactly as I did with the other ones. I need to provide the inputs. I need to say where I want this to be deployed. And essentially, I can now execute that automation tool from a centralized place in a governed environment according to policies. Policies is something we haven't really touched on yet, but you're going to see that very soon. Let's go back to our environment we deployed earlier. And now that you're a little bit more familiar with how those building blocks are created, let's take a look at our YAML. And the YAML for this specific environment is, again, very simple. We have the inputs we provided when we launched this environment. We have the outputs or the links you can see here on the right side, things that the user would like to use, like the connection string or the friendly DNS name for our newly launched website. And then the building block, which is really the core of the orchestration process. We have here 2 building blocks that are Terraform based and 1 Helm based. Now, the dependency mechanism allows us not only to make sure infrastructure part or application part are ready for the next phase, but also help us to improve deployment times by running things in parallel and not sequentially. Usually when we see customers, we see a very long monolithic Terraform file that takes a long time to deploy. Breaking that using the dependency mechanism can really ease this pain, and environments can be launched very quickly. Now, in this dependency mechanism, I want to show you something interesting, and that's the normalization part. So any component, any building block will have an input and output section. Now, let's take a look at this output as an example, that this Terraform will output a connection string, but then Helm will take this connection string and use that for the microservices. So regardless of the automation process or the automation tool, we are really generalizing or normalizing the technology and providing you a very simple interface. So eventually platform teams can really focus on building those amazing building blocks, the IAC logic, and then enable others to build environments out of those building blocks. This is just one use case we see out there for using those building blocks. Now, let's go to something even more interesting, and this is how we eventually enable environments to our end user. And by enable environments, I mean they're not just need the ability to launch the environment and access the environment. They want to see what's important for them. And in this example, you can see a single Terraform file that deploys WordPress application on EC2s in AWS. But honestly, the developer doesn't care about that. He doesn't know WordPress, he doesn't know, or he doesn't know AWS, he doesn't know how Terraform works. And honestly, he doesn't want to learn because that's hard. what he wants to see is the interesting parts for him in this environment and why this environment was built for him, because he needs access to specific VMs that are running WordPress or database. So what Torque provides you is not only the ability to orchestrate and manage environment, but also the ability to go in and show different layouts of the same environment. So clicking on the resources layout, suddenly the end user get a slightly different angle for the same thing. This time, he actually gets only the important information for him. And that's the WordPress application with the IP and the sizing and the MySQL machine. And he can actually click and directly go into one of the VMs. So let's accept the risk for a second. And without too much, I haven't logged into AWS. I don't need any secrets, but suddenly I can go into my newly launched environment and directly access the VMs in this example, so EC2s. So we kind of covered a lot, but one of the things we haven't covered really is what happens when an environment is already up and running for a long time. And one of the things that can happen for sure with Kubernetes, but also with Terraform and any other automation platform that eventually launch entities like pods, endpoint, load balancers, ingresses, or S3 bucket in this example, is drift. Someone logged into the cloud or into a Kubernetes cluster and edited some of the manifests, changed something in the AWS console. Now, one of the things that an environment as a service platform is aiming to do is to help you standardize and really reduce the operational cost of all of those environments that are running. So drift detection is really crucial in order to do that, because we want to make sure that if something is out of configuration, something goes out of configuration, the system will be able to monitor that and alert that. So you can see here a notification that something went wrong. By the way, it's not just a UI indication. We are actually raising an alert to Slack or Teams or Webhook. You can trigger automation based on that. And it's not just that we are showing you or alerting that something was changed. We are actually showing you what was changed. In this case, I changed the tag on the S3 bucket, so the value was changed, and this is definitely bad because we broke something that was defined in the Terraform file or in the standardization of in the standard deployment process. And what we want is not just for Torque to provide us the alert, show us the details, but also to reconcile back to the original configuration. So clicking on reconcile, you can basically see that the environment reconcile now started. And in a few minutes, this Terraform definition will be reverted back to the original state. Or actually, I need to say that the resource in the cloud will be reverted back to the original state that was defined in this Terraform module. So we kind of covered orchestration, management, how the user access an environment and can really consume it. And now we are also covering operational management or operational work on top of running environment, what's referred as day 2 operations. Now, something I really want to show is how we can help you with governance and how we can help you with policies. So, and you can see that the reconcile completed. So let's go to our centralized management section. And you can see here one of the things we already covered, and this is the centralized tagging area where you can set all kinds of tags, custom tags, out-of-the-box tags that we provide, and essentially make sure everything that you're deploying, regardless of the automation process, is basically standardized on that angle. Now, policies is really important because we want to make sure we are deploying in the right way. Regardless of who's defining the IAC definitions, we want to make sure that everything meets the standard and everything is within our compliance program. For example, if we are deploying to ingress in AWS or Azure, we want to make sure that ingresses are not exposed without a certificate, for example. Or maybe we want to make sure that Terraform file, when we deploy them, Terraform modules are not using specific instances or regions that are for sure something we shouldn't use. So just think about the architect that wants to experiment with a new technology. He will just go ahead and download a community Helm chart or community Terraform module that someone wrote. He's not really into the details, and he just go ahead and deploys that. What we want to make sure is that he will deploy that using the environment as a service platform, and the rules, the policies will govern that and will make sure that it's impossible to do the bad stuff. One of the bad stuff we are usually we usually see in organizations is public storage. So let's take Azure in this example, and applying this policy basically means that any deployment that will happen from this moment on for Azure using Terraform in this case, if the Terraform module contains a public storage, basically Torque will enforce that and will make sure there are no public blob storages. Now, you can apply that for the entire organization, or you can say this is something only the development team are not allowed to do because maybe other teams have better experience, they're more expert, and that's okay. But basically applying these policies are now going to be part of every deployment process in the tool. Now, all of those policies, you can add your own, by the way. You can use our out-of-the-box policies, and all of those policies are based on OPA, Open Policy Agent. This is a very strong, very powerful standard for policy as code. So these policies are based in source control as well, and you can basically develop them separately and then add them. If you already have policies, it's really easy to onboard those policies into the tool and just apply them on your configurations. Now, we've talked about tags, so let's see how standardization of tagging during deployment can really help us with cost information. Here you can see, just because we just started February, I clicked on the back arrow to go to January to show you some of the cost information we gathered on this Torque account. You can see here the different cloud providers. We provide visibility to not only cloud providers, but also Kubernetes cluster. And this is really interesting because you can see here how much a specific Kubernetes cluster costs in terms of utilization. And you can see prediction for that or forecast. And you can see that month by month. You can see here how much specific blueprints cost and specific groups or specific teams. In our case, live is basically production, staging, and development. So the ability to add business context in a form of tags to any deployment you're doing eventually get you to a place where cost information or business information is very easy to grab. Now, before we move on to the question section, I want to show you something kind of interesting around Kubernetes. So Torque is not only for IACs, but you can actually hook a lot of different tools into the platform and into the orchestration process. This is an environment I started earlier. You can see 45 minutes ago. This is the actual cost according to Kubernetes. And in this deployment, you can see 3 different building blocks with this red shell icon. Now, in this building block type, we're basically allowing you to execute custom code. We call it the shell building block, and it allows you to integrate with different tools and different CLI processes or existing automation processes you have, like maybe a Python script that needs to execute somewhere. As with other building blocks, it has inputs and outputs. And what you can see here is we executed compliance tool and security tool before we deployed something to our cluster. In this example, we used the tree to go through the manifest and see that everything is configured properly. And then we ran Kubescape in order to make sure that everything is meets with our compliance and security standards. Now, this is obviously executed on the manifests in parallel, and only if those two are passed with the under the right threshold we configured, only then our online boutique portal will be deployed. You can see here the application out there, and all the microservices behind the scenes are playing along together. Now, it's not always enough to just deploy the application using, in this case, Kubernetes. So just apply the manifest. If we want to enable environments to our developers, QA people, or even to our CI/CD processes, we need to make sure the environment is not only secure, but also ready for use. So in this case, we have a quick and very simple script that will wait for the ELB, in this case, in AWS, to be ready so we can actually access the environment. Now, this environment, as it's configured here, can be used for from the self-service for a developer to play with, to debug, for a QA to test, but also for automation tests. So let's say Jenkins, Azure DevOps pipelines, or others, TeamCity, CircleCI, and other, Tecton maybe, can launch this environment. And now it's not only orchestrating the application itself, but it's also containing the security aspects. And it's you can know for sure that once this environment is up, it's also ready for consumption. So think about a classic automation test that will call Torque to launch the environment, wait for a few seconds, then execute the test, and then kill the environment. But this is something we haven't really saw before, and Torque is really excellent in decommissioning all the different resources. Let's go back to this environment as an example. By clicking the End button, I'm basically starting the orchestration process or the decommissioning process, where all of those 8 resources will be slowly deleted from the cloud. So think about the number of cloud entities you have out there that are maybe out of use, maybe not tagged correctly. Maybe you're not sure if someone is using them. Maybe yes, maybe no. With this concept of modeling environments, publishing them as blueprints, enabling them to the different processes in the business, and then allowing policies and duration for those environments, you can really know for sure that the resources out there in the cloud are the right resources. Now we see that with the Kubernetes clusters use case, it really helps in minimizing spend. And by that, eventually you can scale down your clusters, see less nodes running. And by the way, maybe in specific situations, you also want to operate on top of that. So let's say we deployed an environment with a Kubernetes cluster that has 3 nodes and is running a specific application. What happens if that Kubernetes cluster is not really needed anymore, but we want to keep it as just 1 node? All right, how we can operate on top of that and make sure that this is possible in an automated way. So this is something we can help with as well. Now, we kind of touched on the ecosystem already, but I want to add a little bit about that. Once you have this kind of a platform in hand, an environment as a service platform, basically that will centralize everything around orchestrating environment and managing environment. You can see here that once I click on the environment list, I can see all of the environments that are out there. And in this case, it's just environment created by me, but it might be a very long list of all the environments out there in the organization. Now, seeing that, launching the environments, decommissioning the environments, if that's all centralized in one place, a lot of different tools would like to integrate with such a system. So maybe CI/CD tools for launching environment, for upgrading releases, rolling out new artifacts to production or staging, chat ops application like Teams and Slacks and other would like to get notification, or maybe you want to launch an environment directly from Slack. ITSM tools where ServiceNow or others would like to launch an environment after an approval flow. So this is something we can also do. And eventually something that we see a lot, and this is developer experience tool or dev tools that are built for launching environments, maybe on local machines, maybe on remote environments. And using this model of environment as a service, you can basically extract the environment logic out of there and just invoke Torque using CLI or an API. So the ecosystem around the environment as a service tool is very important, because once you have the ability to model environment, you want to be able to consume them from all around in the organization. Now, I think that with that, Colin, please go ahead, and if we have any questions, I think that will be a great time.
Yes, absolutely. As a reminder for everybody else, we only have about 5 minutes left on the session, so get your questions in. To get started, one of the first ones that came in was around when you were showing the cost information. Where do we get the cost data?
Great. So let's go into that for a second. So as I said, everything is tagged regardless of the automation technology. So if it's Kubernetes, we're adding labels. If that's AWS, we will add cloud tags. Now, once everything is tagged, we can go ahead into the cloud provider and grab the actual cost, the real amount of dollars something costs this specific account in the cloud. So if you have specific agreements with a specific cloud provider, for example, we will actually get that information, and this is the right amount you paid for an S3 bucket. It's not based on market price or the list price. It's actually what you paid for that resource. And again, we're getting the context of the environment. So it's not just that S3 bucket. You saw 8 different resources created in the cloud for that specific Tetris deployment. So we are gathering that, and we provide you this entire context out of your specific cloud provider.
Great. One other question that we saw come through, how long does it take to launch an environment? And I think it would help if you talk about some of the more complex environments, right? Some that require multiple different technologies or assets.
Sure. So one of the examples we saw here is kind of a little bit maybe more advanced. This is infrastructure and application. And 2 things I'm going to say here. One of them is that deployment time really depends on the cloud. By the way, we can deploy on-premise as well on different providers like vCenter, like OpenStack, but essentially it depends on the business logic that's executed and the cloud performance. In this example, an RDS takes almost 8 minutes to be deployed. Now that's pretty long. So overall deployment of this environment is around 8.5 minutes. But with the ability to run things in parallel using the dependency mechanism, we can shorten the deployment time as much as possible. And obviously, when it comes to the cloud, different tools, different clouds, different services will have different performance. In our customer base, we usually see environments that are being deployed, I would say deployment duration from 2 minutes to 30, 35, 40 minutes for some very impressive environments with hundreds of services.
Great, and we have time for one more. We just had an interesting one come in, kind of a multi-tier question. So are the resources that you're using for these applications in Torque, do they come from the user's Git, or do they come from our library of resources? And if they come from the users, how do we assure security?
Great, very good question. So everything you see here is out of the user repository, all right? And with Torque, we provide kind of a marketplace of best practices building block, but really the basic stuff. Usually what we see is that customers would like to execute their own stuff. Now, what's really important to say is that those repositories, those automation assets are our client or customer or the end user assets. We don't want to take them. So we are discovering them, but we are not saving them in Torque. All of that business logic is saved in the customer side. We are just orchestrating that. And if you want, get into the doc section of Torque and see a little bit more about the architecture, where our agents are really accessing those IACs and executing the business logic in the cloud provider or on-prem. So in that case, or in this way, Torque doesn't really need those IAC assets, and we are not saving them and not persisting them anywhere.
All right. Unfortunately, we're just about at time. If we didn't have a chance to get to your question, someone from our team will be in touch to answer any questions you have. If you have any more specific questions, you can contact our team via quali.com. I dropped a link to request a demo there. We also offer a 30-day trial of our enterprise and professional packages. You can request to start your trial via quali.com as well. Thank you again to Tomer. Always great in these sessions. This was super helpful. And thank you again for everybody else. We know that your time is valuable and we appreciate you spending some of it with us.